Hello everyone, this is Baron Schwartz. I'm going to wait for just a moment. While this Hangout boots itself up. All right, go ahead and get started. So as I mentioned, my name is Baron Schwartz. I'm the CEO and founder of Vivid Cortex, and we'll be talking today about what to monitor in MySQL. A couple of logistical things. You can tweet your questions to Vivid Cortex with a hashtag, and I'm watching the live stream there. If you're using the comments on YouTube, that does not work well. So I will not be able to see and answer your questions there, but if you tweet the questions to me, I'm happy to answer anything as I go. The slides in the video will be available. We'll have the recording online after this, and then we'll post the slides. And if you signed up for the webinar, then you'll get an email with a link to the slides in the video. Otherwise, you could watch our blog or watch Vivid Cortex on Twitter. And I personally always enjoy hearing from you. So feel free to email me, baron@vividcortex.com, or contact me on Twitter, and I'll have my contact information again at the end of the presentation. So just to kind of set the stage here for how I'm going to approach this, this is not a pitch about why Vivid Cortex is the best monitoring solution or anything like that. Of course it is. I founded the company, so of course I think it is. But seriously, there's a lot of stuff here that Vivid Cortex doesn't do. Some of it might not ever be done or provided by Vivid Cortex. And what I'm really trying to do here is to help people who are curious about how to monitor MySQL and find it overwhelming, or actually Postgres as well, because a lot of this is database generic and applies equally well to Postgres. So if you find that topic overwhelming, what's the quick way to cut through all the fluff and all the confusion online? And I'll show you some things that are suggested on the internet that I don't agree with, and get monitoring really quickly. And monitor the most important things so that your databases stay fast and available. So I want to get you 95% of the wins without too much work. And I particularly want to avoid some of the harmful side effects of monitoring badly. So what we're trying to go for is the things that are easy, the things that are desirable together. That's my ideal of what to monitor. It's the things that you can easily do and the things that are the best to do. The overall goal with monitoring things, there's basically two kinds of monitoring that you can do, or two categories of functionality that most monitoring tools present to you. One is health checks, and that's sort of, you can think of it as being like Nagios style, critical, warning, and okay states. Generally kind of stateless, doesn't have a memory of the past. You're running some, in a lot of cases, something like a check for a condition being true or false, or a check for a metric exceeding a threshold, something like that, and you get back this critical, okay, and warning state. The other kind of monitoring that you frequently see is time series charts and graphing. And I really don't think that that is very helpful, particularly for keeping MySQL high performance and online and fast, and highly available, I mean, because a lot of those metrics are just things that were convenient to build into the server as the server was being built by the developers. You know, they had something that they were curious about, maybe it was useful during development, whatever. There are hundreds of metrics in MySQL that you could potentially monitor and put thresholds on, and all but a couple of them are going to just cause you nothing but false alarms. So what we want to do is avoid false alarms, because if you've ever worked in a place with lots of false alarms, you know that everybody immediately sets up filters on their email and just filters everything to the trash, and then the monitoring system becomes shelfware. It's ignored, and as a result, it doesn't get improved, and it's kind of a downward spiral from there. So what I'm going to try and help you do here is look for the smallest set of things that are the most broadly useful and provide the biggest bang for the buck, without all of the false alarms. So we're really going to try and keep all of the alerts in particular actionable. Now, monitoring can be looking at systems as a human. It can also be having a system like Nagios look at it and send you an alert. So I distinguish between monitoring and alerting. And in particular for alerting, we have to have a very low tolerance for the potential of a false alarm, because if you have potential false alarms, you're going to get them and people will ignore them. False alarms are much more damaging than is commonly supposed. I'll try and remember to add a link to Dan Sliman's blog post in the resources that I'll give you at the end of this. But if you're familiar with Dan Sliman, he's got a great blog post called Car Alarms versus Smoke Alarms, or something like that, Fire Alarms versus Smoke Alarms. I can't quite remember the title of it, but I'll look it up. And it explains why you need to have a much lower threshold of false positives and a much lower threshold of false negatives than you would intuitively suspect in order to get good quality monitoring results. So that's one of the things we're going to do, is try and make sure that every alert that we send is something that a person can actually act on to resolve a situation. There's a couple of principles that I apply to this. My overriding principle, and in fact what Vivid Cortex was really based on, is this idea that you have the systems in order to do work for you. And so monitoring whether the work is getting done or not is the most important thing. If the system is getting the work done, in the case of database, that's queries. If it's getting those queries done with good quality, then there's really no problem that needs to be immediately resolved. There may be an impending problem, like the disk might be starting to get full and it's going to fill up soon, but those capacity resources kind of fall into a different set of things that you might look at. And so my principles in general are that I want to monitor whether the work is getting done, and then I combine that together with other things that are happening on the system, like other processes that are running, because it's rare that you have a database server where only the database process is running. And metrics and status that you can get out of the system. And in our case, we have an agent that captures a lot of data out of the network as well. So we're sniffing the TCP traffic and getting metrics out of that. And then finally, the resource usage and constraints and contention for those. And that would be, for example, the disk getting full. And you want to take all of these things and stitch them together to get a whole picture of the health and availability of your systems. And finally, there's every technology has bugs. It has features that don't work very well, or has features that are kind of, give you enough rope to hang yourself with, so to speak. And so it's well worth learning what those system-specific things are and making sure that you check for those things very specifically. So monitoring, in my opinion, should not be generic. It should not just be throw a bunch of metrics at some sort of black box and use anomaly detection or something like that. I really don't believe in that. I believe in using our experience of what commonly breaks to inform how we design these monitors and alerts. So what I suggest not doing is not Googling things like top 10 things to monitor in MySQL, because those lists, I've looked at them myself, and they include a lot of things that are almost guaranteed to cause you lots of false alarms. The same goes for a lot of Nagios plugins that are commonly available for MySQL and other systems. Many of them are designed by somebody who just looks at the output of something like show status, and maybe looks through the MySQL reference manual and says, what kinds of alerts could I possibly put on these 358 variables? And you're pretty much going to get 357 false alarms every minute from that. This is a screenshot of the documentation from one of those plugins. And that font is tiny. I'm not even sure, I don't remember whether I screen captured the entire page documenting all of the alerts in this Nagios plugin or not, but there are just way, way too many things that plugin does. And I looked at them, a lot of them were just sort of laugh out loud ridiculous. So I do not suggest just using any old Nagios plugin. I wrote some called the Percona monitoring plugins when I was at Percona, and I still believe in those. Those are very useful, good quality. They're formally tested, and they're tested in the real world. And they go very well along with this philosophy that I'm espousing here. So especially, there's a lot of database rules of thumbs like cache hit ratios and rate of bad queries, ratio of one counter to another counter, and things that can't be fixed directly, right? Like replication delay, that they might be true that replication is delayed, but there's really nothing that you can do to fix it in a lot of cases. So those are things that I am very reluctant to alert on, and in many cases I strongly advise against alerting on them. Particularly ratios and cache hit ratios are the worst of the worst. They are nothing but false positives. And the reason that that's true is that it's not a question about whether work is getting done or not and how good the quality of the work is getting done. They are very much secondary things, and they're properties of the workload and the application. And they're not actionable. You can't fix them directly. So if you send an alert that can't be fixed, you're doing it wrong. I often have quotes of various kinds of scripture, and this just happens to me from my little calendar of Rumi poetry hanging next to me. I glanced over and looked at it while I was writing these slides, and I thought, that's perfect. Let's give up the tricks and the cleverness and not try and do monitoring in any sort of clever or, sort of like think of ourselves as having found a clever way to do monitoring. Let's just do plain old monitoring, just very straightforward, and we'll get the best results. So now I present to you a list of 10 things. This is my own top 10 list of things that you should be concerned about monitoring. So let's just dig right into it. And I may go through this pretty quickly. I'm not planning to take a whole hour on this. So I'll save you some of the time there if you blocked out an hour for this webinar. Okay, so let's dig into number 0. The 0th most important thing that you should be concerned about is whether your database is actually up and running and can serve queries. So the way to test that, of course, is not to check whether the database is actually running, but to test whether you can connect to it and run a useful query. And by useful, I mean you shouldn't be running like a monitoring query like select one. If you can connect and run select one, you've proved that the server process is available, but very little else. You've not proven, for example, that your data is there. You've not proven that your data is not locked. So you need to run some kind of useful query, something that actually touches real application tables, preferably with the real application user, and even more preferably from a real application host, so that you're not, for example, falsely thinking that your application can get to the database when a firewall rule has changed and only the Nagios server can get to the database. So you want to try and make these checks as realistic as possible and simulate the application does its real work. So you pick a query, like if it's a web application that has sessions, a lot of web page loads are going to begin with a check of the session. So go ahead and do like the session query or something that should be very fast and not intrusive, but is a real query from the application. Being able to connect to the server is actually quite a big deal, and connections in many cases, it varies from database to database. Connections in Postgres are thought of as more heavyweight than they are in MySQL, where it only consists of starting a thread inside the server. But there's always little special case things, and in MySQL, one of the Achilles heel is a sort of, I'll just go ahead and call it a very silly design about how authentication is performed by default, where the originating host is part of the authentication credentials. And so it by default does a name lookup, a forward and reverse DNS lookup to figure out who's trying to connect. And that causes so many problems. If it hasn't caused a problem for you and you don't have skip name resolve set, you should probably configure that, because at some point someday DNS will get overloaded or slow or unavailable, and everything will be failing to connect to the database. So available, is the database server running? That is, and connectable and usable. That's the most important thing. The next thing that I've seen cause a lot of troubles, and I did actually, while I was a consultant, I did a fairly exhaustive study of several hundred downtime incidents that I had been involved in, and tallied up all of the causes, the sources, and the resolutions of all of these problems. And database logs filling up the disk is a very significant problem. And there's different ways that can happen. For example, one of the common things is that if the database's slow query log starts to get large and an alert goes off, says the disk is getting full, somebody SSHs in and does an RM on the database log file. But that doesn't fix the problem, because the database, the server process, still has a file handle open to that file. So you've removed the inode from disk, but you have not actually, it's still being held open in memory. And if you use LSOF, you'll be able to see it as a deleted file in memory. Still an open file handle. And it will continue to fill up. The disk space will not be freed. You will run the server out of space and potentially crash and do all sorts of nasty things like corrupt your data. So the slow query log, and that's one of the reasons we don't use slow query log parsing at Vivid Cortex, and we don't do things like automatically enabling and disabling your slow query log, because the operational hazard of that is pretty high. So number one is the logs and the disk. And number two is actually the disks, regardless of the logs. Disks getting full is one of the most common problems with database servers anywhere, whether it's log files or replication log files or the data itself or something else happening on the server. Those disks just tend to get filled up, and somebody goes and runs a batch job and writes it to temporary files, and boom, partition fills up and everything stops. Now, ideally, you would have some memory of how fast the disk space has been decreasing, and you would do something like, you would either do the derivative of that and average the derivative, which is sort of a simple rudimentary form of linear regression, or you would do a linear regression, or perhaps even a fancier regression, to figure out how long is it likely to be until the disk fills up. Because in my mind, it's a lot more useful to have a 30-day window on the disk filling up or a 7-day window on the disk filling up than it is to have a 95% threshold. Those thresholds that are fixed percentages are just notorious for generating all sorts of false alerts. But given that disks are also notorious for crashing servers, it may be an evil that you need to deal with unless you want to spend a little bit of time. That's one of the things that we don't do in Vivid Cortex, but we will someday. The third big thing that I've seen is that a lot of the most difficult problems to solve in databases are short periods of unavailability. Small stalls, freezes, lockups. People use a variety of different words for them. These became really serious around 2010 when MySQL in particular had a lot of scalability problems on multiple CPUs, and everybody was running it on lots of CPUs and lots of memory. The server itself has gotten much better since then, but application use patterns still present a challenge for a lot of cases. So that would be, for example, select for update queries locking against each other, or running an alter table that locks a table and then everything piles up against that. So these small spikes or stalls are a critical availability problem. And if it's part of your application's normal day-to-day life, then the way it happens is it starts small. It starts in milliseconds, and then it becomes fractions of a second, and then seconds. And people typically don't notice that until it's maybe 10, 30 seconds, 2 minutes, and it's very difficult to diagnose because you won't see it. By the time you've gone in to look at the server, it's cleared up and you don't have the evidence. This was such a difficult problem that when I was working heavily on Percona Toolkit, I wrote a tool called PtStalk. And we detected, diagnosed, and prevented a lot of serious problems that way. So that's one of the tools that you can use for that. Another is Vivid Cortex's adaptive fault detection. And that does an even better job at detecting the small little spikes a second long and helping you to find them and resolve them before they get bigger. There's a couple of things that you want to do when one of these little spikes happens. The most important thing is you want to gather a lot of information, everything that you can, about everything that's happening on the server. You want all of the information so that you can diagnose whether it's a server problem, like an internal scalability or mutex problem, something external to the server, like another process that's chewing up swap and causing everything on that server to pause, or maybe something that's an application performance problem. So those are the three broad classes of stalls that I have seen on servers. And new ones will emerge from time to time. So it's something that's difficult. You can't necessarily just write fixed rules to account for it. because the symptoms of future ones may look different than the symptoms of the present ones. This is where that philosophy of monitoring whether work is getting done comes in handy, as I mentioned earlier. There's a few kind of classes of things. After this, I'm going to talk about transactions and threads. So the most important thing is the work getting done, right? So that's queries. But in order to get any work done, you have to make a connection. So that becomes kind of by proxy one of the things that you need to watch really carefully. The number of connections, and particularly whether the number of connections is reaching towards a max connections limit, is really important. And in a lot of systems where there's either connection pooling in the application, like there might be in JDBC or in Go's database SQL library, or in something like a proxy in the middle, like PG Bouncer or PG Pool, a lot of those things can be difficult to change without taking down and restarting some part of the service, which may be considered very intrusive, like it might be unplanned maintenance, and so it might have to be deferred until there's a maintenance window, or it might count against your availability SLAs or something like that. So you want to be watching this in advance and making sure that you're not creeping towards your max connections to the point where applications are going to try and connect to the database and fail to connect. And in MySQL, there is also a max user connections limit. So that can be set per user, so that you can set some users can have this many connections and some others can have that many. And you want to be careful about connections on a per user basis in that case too. Now, another thing that you need to know is whether your app can't connect. At present, probably one of the best solutions for that is logging and making sure that you have visibility into that log on the application side. In future releases of Vivid Cortex, we're actually going to capture that happening on the wire and alert you about that as well, because we can see TCP, we see all the TCP traffic to the server, so we'll catch when a server's not allowing a client to connect. So that was connections. Number 5 is processes. And process is kind of a generic thread, process, connection, backend. I usually call it a process because it seems like the best one-size-fits-all word for it. There's a few things that you want to look at here. Are any processes running queries that have been going for a really long time? Because those tend to prevent things like background purge jobs from running on the server. For example, auto vacuum or InnoDB's old row version purge. The same thing with long-running, long idle processes. If idle processes are hanging around, those can represent, for example, contributions towards the max connections limit. And in specific case, depending on the technology, like in MySQL, it can represent a thread that is open on the server and maybe making the operating system less efficient at scheduling threads. Too many running processes or running queries, too many of these connections that are active at a given time, too much concurrency on the server is another serious problem. My rule of thumb for this is generally that a process or thread on the system can be considered to be idle, in which case it doesn't count towards this limit, or it's busy. If it's busy, it's using CPU, or it's waiting for some external resource, in which case it's not using CPU. So as a general rule of thumb, kind of on the average, if you have twice as many active threads, processes, queries, concurrency at one time as you have CPUs, you're probably running into a problem. And if you go much higher than that, that almost certainly represents queuing waiting for CPU time. So you're overloading the server, and that's something that you need to know about and rectify. It's not something that I would alert on specifically, but I probably would fire task to gather information about what's going on. And then the process or backend states are very important. If they're locked or waiting, or if they're in a statistic state, in MySQL particularly, that means that the query planner is trying to plan, which often is a sign that there's too much contention and concurrency inside InnoDB. And there's a few other special cases. Remember I said you want to build your monitoring very specifically around the sharp edges of the technology. Well, in MySQL, I mentioned earlier the skip name resolve. The classic symptom of not setting skip name resolve is an unauthenticated user in the process list. And so if you're seeing unauthenticated users, that's kind of a trigger for you that you should probably set that parameter. For transactions, we have some of the same considerations. We really don't want transactions running too long. It represents, in most cases, locking of resources. It may be explicit row locking that blocks other transactions, or it may just be keeping old row versions around so that the database can't purge them from history. You also want to watch out for too many transactions, same thing, that concurrency that I was just talking about. And inside of InnoDB, in particular, you can see the size of the transaction queue in show InnoDB status. And then there's locked and blocked and waiting transactions. You really want to be aware of how many things are actually blocked and unable to get their work done. One of the common things that fails in any distributed system, but to be fair, it's been, had a pretty patchy history in MySQL of being one of the common things to fail in particular, is replication. So the first thing that you want to do is check whether replication is running. And that's somewhat technology specific, but for example, in MySQL, you want to check that both the SQL thread and the bin log fetching thread are both running. And in newer versions of the server where you have parallel replication, you want to check that they're all running. You also want to check that whether there's replication lag. You typically will not alert on this. The replication lag that is fixable is usually replication lag caused by replication not running. If you are overloading your servers, you will get replication lag and it will be spiky. So if you put a threshold and an alert on replication lag, it's going to, as the workload fluctuates on replication and replication catches up and gets behind and catches up, it's going to repeatedly cross that threshold. And so you will repeatedly get alarmed on this. And there's something odd about this. It's almost a cultural thing. I've experienced it several places where there's a check on replication lag and an alert that results from it. And something psychological, you just can't convince people to stop it. You see alerts on replication being delayed every 20 minutes. I have literally seen that in a relatively small IT shop. Every 20 minutes, replication is behind. Well, what can we do about it? Nothing. Replication is behind because we're running really long transactions on the master, and when those transactions replicate over to the secondaries, it takes a long time. And while it's taking a long time, replication gets delayed. And that's just a fact of life, and there's nothing you can do other than completely change the way you're using your application. So that's why I really suggest against alerting on that. The third thing about replication is you want to make sure that your replicas are a true and correct and faithful copy of the master. And this is easier said than done. In MySQL world, there's now a tool in MySQL Utilities, the official MySQL Utilities by Chuck Bell and friends, that can do this. The tried and true tool for this that I wrote myself in 2006 or something like that, maybe 2007, I'm not sure, is it's part of Percona Toolkit now, and it's called Table Checksum. So that's kind of a classic oldie but goodie. And in Postgres, I honestly don't know what the answer here is. I haven't looked into it that deeply. But if you're trusting that replication is accurate, I can tell you from personal history that it's probably not. And the only way that replication gets really accurate and replication gets really good in the product itself is if these kinds of, if you do devil's advocate checking of whether replication is creating a faithful copy of your data on the secondaries. And the only way to do that is to be like a QA engineer. Have you heard that joke about the QA engineer that walks into the bar, orders a beer, orders 999,000 beers, orders -1 beers? That's the kind of thing that you have to do. And it's usually very difficult and technical to detect whether replication is actually drifting or not. Number 8, and this may surprise you, you might have thought that I would put query performance right up front, but I'm more concerned about whether things are up and running correctly, whether they're running fast, and whether there's something to improve about the way that they're running, we're getting towards, lower on the food chain, and these are certainly high value activities to do, but generally not urgent. And so we would usually not alert on anything about query performance. We may in the future alert on some things about query performance in Vivid Cortex in the future, but that's going to take a lot of work to make something intelligent enough to do that without false positives. So I don't have that solved yet. So generally, we want to look for top queries to optimize. This is kind of interactive monitoring. This is something that you're going to do as a human, not generate an alert on. You're going to look at and inspect your workload. You're going to slice and dice top queries. You're going to look for queries that are that have outlying response times and that can indicate flaky query planner behavior, like the choice of a different index sometimes, depending on the query plan or the statistics, or those outliers in performance might indicate short stalls that you should look into, that kinds of things. You also want to look for queries that aren't using indexes, using either partial or full scans of the table or of an index, or queries that are using poor indexes. Those are both things that we can sniff off of the traffic in MySQL. We can sniff right off the network. And getting down to the data and table and schema optimization, look for indexes that are duplicates or unused. There's a tool in Percona Toolkit for that. And we'll probably build that feature into Vivid Cortex in the future as well. And queries that return errors and warnings to the client. In other words, the application is seeing some errors and warnings. And there's really no good tools for that today, other than Vivid Cortex. We capture that on the network. But if you're not using Vivid Cortex, you probably just need to be really vigilant and use a good log aggregation tool and catch those things in your application. It can be really difficult to do. It's so easy as a programmer to miss an error condition that comes back to your program, and you either you don't catch the error, or you don't log it. And so it can be pretty easy to miss those kinds of things, unfortunately. And it can be from any kind of a thing, from a syntax error to a privilege. You don't have privileges to run that query or something like that. Even worse, sometimes it can be intermittent, like you're constructing your queries by concatenating strings together instead of using prepared queries, for example, and you don't have some input checking, and so you think you're querying with a number in your query, but you're actually adding some string, like some garbage value in. And so occasionally you might get those kinds of errors. But those are the little things that all pile together in an emergency. An emergency never has a single root cause. It always has a chain of causes that are jointly sufficient, but individually not sufficient. And so catching these little things is really high value proactive work for preventing things from accumulating enough technical debt in the future that it will bite you in a bad way. And then the last thing is monitoring the operational aspects of the server. You'd be surprised how many people's servers crash and restart and they don't actually know. And you can tell pretty easily with just looking for the uptime counter. And there's one of those in MySQL in the show status, and there's also a function to get that out of Postgres. And configuration change events. When somebody changes a server configuration setting, there's a couple of reasons you might want to know that. One is if you're trying to diagnose something and you have an event that the configuration was changed around the same time as you saw a change in server behavior, you'd probably want to examine that pretty carefully. And then the other reason is you just want to be aware of things like somebody has gone and reset, changed a server configuration setting, but did they do that through, did they put that into configuration management as well? Or is the server going to revert back to the old configuration after it restarts? And messages in the error log. So it's pretty important to keep an eye on that error log. And for this, my best suggestion, again, is to use some kind of log aggregation, whether it's remote syslog or something like Splunk or what have you, to make sure that you have visibility into your error logs. Typically, things that are written into the server's error log are, you should probably know about them. Your error log, you really want it to be quiet. So let's sum up. First, the principle, let's alert on work that's work getting done or not work getting done if you can. And that typically means queries or requests or commands, depending on what your database of choice is. I would not suggest, for example, staring at pages full of graphs and asking what they mean, because most of the counters and metrics that come out of most systems are essentially inherently meaningless unless you have some kind of a hypothesis about something specific that went wrong and you're looking for evidence to support or reject your hypothesis. And then do plain vanilla simple monitoring of the basic brittle edge cases in your specific product. So, replication, for example, or failure to log in, that kind of that Achilles heel in MySQL, DNS lookups that I was mentioning earlier. There's a couple of things that we can do in Vivid Cortex to help some of this. It's not complete by any means, but for example, we have easily the most complete and highest resolution information on query execution that you can find in the market. We also do monitor replication, and we generate events from things like server configuration changing. We have the best fault detection out there to catch the little small stalls, and there's a bunch more that I'm not going to talk about. Again, I don't want to, if you're interested, feel free to look at it, but I don't want to bore you with it here. And there are some other resources that I wanted to mention. First of all is my book, High Performance MySQL 3rd edition. And there's a website, highperfmysql.com, where you can download a sample chapter and learn more about that. The Nagios plugins, the Percona monitoring plugins, which I wrote when I was at Percona, those are very high quality, and you can download those freely from percona.com, along with a lot of other good stuff from Percona for that matter. And Vivid Cortex, obviously, I think it's great. My company, my life's work at this point. And I encourage you to sign up for a free trial. Most people report to us that they find something that they did not know about their systems, and in many cases something very important that they're really glad they found out. So it's 15 seconds to install, it's 2 minutes to insight. You will find something that you didn't know, I'm pretty sure of it. And feel free to contact me personally. My email address, my Twitter, my LinkedIn, connect to me. Always love hearing from you. And with that, I haven't seen any questions, and I don't think that there was a whole lot left to question here. So I'll wait for just a moment in case anybody wants to tweet a question to Vivid Cortex. And then I'll go ahead and wrap up, and we will email you a link to the slides and recording afterwards. All right, looks like no further questions or comments that I'm seeing. So thanks everybody, hope this was interesting and informative and helpful. So go forth and monitor some more and let me know how it goes. Thanks a lot.